My dear student, I am welcoming you to my YouTube channel Learning Agent. Today I am here with you with a numerical solution of class 10 Concise Physics exercise 8P. So this is video number 7. So let us start without any delay. So this is the question number 21. So before this, from 1 to 20, there is more video, so please watch those video also. The link of those video is given in the descriptions. So let us start with the question number 21. Here it is mentioned that a resistor of 6 ohm is connected in series with another resistor of 4 ohm. So it is connected in series. So let us do it step by step. First of all, let us draw the circuit diagram so that it become easier to you. So what is said, a resistance 6 ohm is connected in series with another resistor of 4 ohm. So then a potential difference of 20 volt is applied across the combination. So the voltage is also applied here. You see, just 1 minute. So here voltage V equal to 20 volt. So question is that calculate the current in the circuit. So first case. So to find out the current in the circuit, we will apply Ohm's law. V equal to IR, where V is the voltage applied, I is the current flowing through the circuit, and R is the equivalent resistance of the circuit. So here you see these two resistors are connected in series. So the equivalent resistance R will be equal to 6 plus 4, because in series the resistance get added to find out the equivalent resistance. So it is 10 ohm. So from V equal to IR, if I put the values of V is 20 volt and I don't know what is I, we will have to find out. R is 10 ohm. So on simplification we get I equal to 20 by 10, that is 2 ampere. So the answer of the first case, it is A. The current flowing in the circuit is 2 ampere. So now come to the second case. Potential difference across the 6 ohm resistance. So if I find out the potential difference in the 6 ohm resistance, that is between this point and this point, between 6 ohm resistance. So here we know the current is I. Current I equal to 2 ampere, we have already find it out, and resistance R1 equal to 6 ohm. So the voltage against this 6 ohm resistance will be equal to I1 R1, that is 2 into 6, that is 12 volt. So it is done. So hope it is very clear to you and you could understand this very easily. So let us find the final solution of this. So this is the final solutions of the question. So you can pause the video and write it down. So without any delay, we are going to the next questions. Next question is question number 22. Two resistors of resistance 4 ohm and 6 ohm are connected in parallel. So first of all, start step by step. We will always start step by step, then the problem will be very easy. So first what is said that two resistance 4 ohm and 6 ohm are connected in parallel. We have drawn the circuit 6 ohm and 4 ohm connected in parallel to a cell of to draw a 5 ampere. So it has been, these two are connected in a cell. So let the voltage is V in the cell and the current drawn is I equal to given 0.5 ampere. So current is given, so from the cell. So in this is the given. So as per the given data we have drawn the circuit. Now in A, draw a label diagram of the arrangement. So A is done. Now B, portion B, calculate the current in each resistors. So we have to find out the current in each resistors. So current I is coming here and it will divide in two resistor. So if it is I1 and the current flow through the resistor 6 ohm is I2, then we can, and the voltage difference I don't know. So if we first of all find out the voltage here, then it will be very easy to find out the current in the each resistors. So first of all find out the equivalent resistance of the circuit. If the equivalent resistance is R, then we can write 1 by R equal to 1 by 4 plus 1 by 6. On simplification we are getting the LCM is 12. So here you can write 3 plus 2. So 5 by 12. That is equivalent resistance will be equal to 12 by 5 ohm. As from Ohm's law we know V equal to I into R. So here V will be equal to I is 0.5 ampere. So 12 by 5. So if I cancel it out, I get 0.1. So on multiplication I get 1.2 volt. So the voltage V here is 1.2 volt. That means the voltage here is 1.2 volt. So in two terminals of 4 ohm resistance, the voltage is V and the same voltage is there in the 6 ohm resistance. So if current is I1 in 4 ohm, so again apply V equal to I1 R1. So in case of 4 ohm resistor, this is coming I1 into 4 and V is 1.2. So we are getting finally I1 equal to 1.2 divided by 4 equal to 0.3 ampere. And in 6 ohm resistor we are getting in similar way V equal to I2 into 6. So 1.2 equal to I2 into 6. So I2 is coming 0.2. So in case of question number B, the I1 and the currents are in 4 ohm resistance current is 0.3 ohm 3 ampere, and in case of 6 ohm resistance current is 0.2 ampere. So hope you understand this easily. Now get the final solution. So this is the final solutions. This is the circuit diagram and this is the solution. So let us go to the next questions. Question number 23. Calculate the current flowing through each of the resistors A and B in the circuit from the figure. So here the circuit is given, so we'll have to find out the current flowing through each of the resistors. So here you see we'll have to find out first the total equivalent resistance of the circuit. So here from the circuit it is clear that 1 ohm resistance and 2 ohm resistance are connected in parallel. So if we simplify this with equivalent resistance, then we are getting the circuit like this. This is 2 volt and this is equivalent resistance. So if the equivalent resistance is R, so we can write 1 by R because it is parallel circuit. So 1 by 1 plus 1 by 2. So this is coming 2, 1, it is 2 plus 1, that is 3 by 2. So R is coming 2 by 3 ohm. So if the current flowing through the circuit is I, then I is coming like this 2, that is I equal to V by R. So this is coming 2 volt by R is 2 by 3. So that is coming finally 3 ampere. So the total current in the circuit is 3 ampere. But we will have to find out current through the each resistors. As the voltage is 2 against each resistors, so current I can find out if current is here is I1 and I2. So you can apply Ohm's law, V equal to I1 R1. So V is here 2 volt, I1 I don't know, we'll have to find out, and R1 is 1 ohm. So in case of, so that is I is coming 2 ampere. In case of 2 ohm resistors, again apply same formula, I2 equal to I2 into 2, I2 into 2. So it is coming I2 equal to 2 by 2 equal to 1 ampere. So we need not calculate this portion. We can simply find out the current by doing only these portions, okay, in this case. So hope this is clear to you. So we can go to the next questions, 24. So this is the solutions of the 23 question number. Now let us go to the question number 24. In the figure, calculate the total resistance of the circuit. So first of all, we can go to the step by step. So here you see the total resistance. Here this is 200, this is R, this is the current. So here two resistors are connected in parallel, but we don't know the value of R. So to calculate the equivalent resistance of the circuit, we need to find out the value of R, which will be the answer of second questions, B. Here as the current I in the circuit is 0.4 ampere and voltage applied is 4 volt, we can find out the equivalent resistance. If the equivalent resistance of the circuit is R1, so we can apply Ohm's law, V equal to I into R1, that is V equal to 4, I equal to 0.4 into R1. So R1 is coming 4 by 0.4, that is 10 ohm. So here total equivalent is 10 ohm. So from the circuit we can write 1 by R1 equal to 1 by 20 plus 1 by 10, because this is the total equivalent resistance. So no, so this is not 10, this is R, this is R. or on simplification we can put 1 by R1, we have got 10 equal to 1 by 20 equal to 1 by R. So if I this is plus, so on more simplification we get 1 by R equal to 1 by 10 minus 1 by 20. So it is coming 22 minus 1. So it is 1 by 20. Meaning the R, value of R will be 20. So here value of R is 20. So we have got the total resistance of circuit. So the total resistance option, question number A, answer is 10 ohm. Question number B, answer is 20 ohm. Now question number C, the current flowing in resistance R. So again we will apply V equal to I1 R1, I1 into R. I1 is the current flow through the resistance R. So V equal to 4 volt, I1 equal to, we don't know, R is 20. So I1 will be equal to 4 by 25 equal to 0.2 ampere. So current will be 0.2 ampere. So this is done. So let us find the final solutions. Yeah, this is the final solutions. So please pause the video and write it down. So we can go to the next questions. The question number 25. So you can pause the video and try it yourself. So you try it. So hope you have tried it. So let us solve this. So the question is, a particular resistance wire has a resistance of 3 ohm. Suppose this is a wire. This is an wire which resistance is, what is said? It is said that per meter, if it is, suppose this is 1 meter, this is 1 meter, so per meter resistance is 3 ohm. So this is 3 ohm, this is 3 ohm, this is 3 ohm. So the total resistance will be what? Will be a particular resistance wire has a resistance of 3 ohm per meter. Find the total resistance of 3 length of this wire, each have 1.5 meter long. So if I take a wire, this is 1.5 meter length, there is 3 portions, there is 3 length. So this is also 1.5, this is also 1.5. So parameter is 3 ohm, it is 1.5 length. So here the resistance R1, it is R2, and if it is R3, then R1 will be equal to 3 into 1.5, means 4.5 ohm. Similarly R2 will be 4.5 ohm and R3 will be 4.5 ohm. So the total resistance of this wire will be, R will be equal to what? 4.5 plus 4.5 plus 4.5 equal to 13.5 ohm. Correct? So this will be 13.5 ohm. So the total resistance of three length of wire, each 1.5 meter long, in parallel. So these are not in series. If they are in series, then it was the resistance would have been 13.5, but this has been connected in parallel. So we have to draw the circuit again. Because they are connected in series, they are connected in parallel, not in series. So here R1 is 4.5, R2 is 4.5, is 4.5. So in case of parallel circuit, if the equivalent resistance is R, we can write 1 by R equal to 1 by 4.5 plus 1 by 4.5 plus 1 by 4.5. So this will be, on simplification, 4.5 is the LCM, here will be 3. So finally we are getting 1 by 1.5. So the R will be 1.5 ohm. So the total equivalent resistance of the circuit will be 1.5 ohm. So question number A is solved. A is solved. Here resistance is 1.5 ohm. Now come to the question number B. The potential difference of the battery, which gives a current of 2 ampere in each of the 1.5 meter length when connected in the parallel to the battery. So if it is connected to the battery V, with V, I don't know what is the voltage V, we will have to find out it. So if the current flow in this, each of the resistance is given, if the current flow is 2 ampere, 2 ampere, so we can apply here the Ohm's law, V equal to I1 into R, R1. So here V equal to, we don't know, I equal to, we know, 2 ampere, and R1 we know 4.5. So here if we multiply it, we get 9 volt. So the voltage applied here is 9 volt. Now question number C. The resistance of 5 meter length of a wire of the same material but with twice the area of the cross section. Now if I do it here, you see if the length is suppose if length is 5 meter long, so we know that the resistance per meter is given 3 ohm. So for 5 meter it will be 5 into 3, so this will be 15 ohm. So but it has been told that 5 meter length of a wire of the same material but with twice the area of the cross section. We know that if the area of cross section, the resistance varies with 2L by A. If A increases, if the area increases, the resistance decreases, and if the area decreases, the resistance, if the area increase, then resistance decrease. If the area decrease, resistance increase. So in this case, if the wire is doubled, the length of the wire is doubled, not the length, if the cross section is doubled, so the resistance of the 5 meter wire will be 15